All right, we have reached the last video of this unit, and we are going to be just looking at the different methods that you could be using to solve equations that might involve the distributive property and different ways, well, just the two major ways that you would be able to solve these kinds of problems. You've encountered some of this stuff before, so this should be a refresher. It doesn't matter what way you do it. It really doesn't. Some are easier than the others in different cases, but they'll get you the same place. So it's really what your preference is and what you think will work best in the situation that you have. Method 1 is just to divide first. So you know that when you're solving an equation, you are using opposite operations. Your goal is to get your variable, when you're solving, to be all by itself so that you can find out what it is. Because, that's why we use it. They represent something. We want to know what that something is. Okay, let's start here. So I'm just going to talk through the way I'm thinking as I'm solving this. My goal is to get d over here by itself, and I'm going to be using method 1, divide first. I'm noticing that this entire bit, d plus 5, is being multiplied by 3. And I'm working this out. I want to get d by itself, so the opposite of multiplying by 3, and I'm just going to write what I'm doing in the side here so you can kind of refer to it. What I'm going to do is the opposite operation of multiplying by 3, which is dividing by 3. And when you do it to one side, you have to do it to the whole thing because we have to keep the balance of equality. So if I divide this by 3, I have to divide this by 3 too. Dividing this side by 3 cancels that 3 out, and I'm left with d plus 5. On this side, I have 45 divided by 3. That's just 15. Now I'm looking at this. What do I need to do to get d to be isolated all by itself? It's having 5 added to it. The opposite operation of adding 5 is minus 5 to both sides. So if I subtract 5 from this side and I subtract 5 from that side, well, these are going to cancel out, and I get d is equal to 15 minus 5, 10. That's a 10. I'm not good at writing zeros, apparently. That's a 10. Wow. Anyway, method 2. This one is using the distributive property first. We're still going to get d is equal to 10. We're just going to do it a different way. Distributive property, remember, is where you distribute this 3 across the two things in the inside. So 3 times d is 3d. 3 times 5 is 15. And then we still have equals 45. I'm going to do that same line down here to show you what I'm doing. So here I distributed. And then I am looking at this. I have 3d plus 15. I cannot say, this is a mistake a lot of people make. They're like, okay, d is being multiplied by 3. So I'm just going to divide by 3. Again, this is wrong. I'm going to divide by 3 on both sides. Now what happens is when you're dividing by 3 on both sides, it doesn't just cancel that out. You're also affecting the 15. So you can't do that because you're not really accomplishing your goal of getting rid of stuff. You're just moving stuff around. So let's go back and look at this again. So we had 3d plus 15 is equal to 45. What I will do instead is get rid of this 15, move it over to the other side so that all that's left on this side is that term with the 3 and the d, right? So I will do minus 15 to both sides. If I do minus 15, then these will go away. 15 minus 15 is 0. So I'm left with 3d is equal to 45 minus 15 is 30. Now that's better. Now we just have this one term here. So if I do the opposite of multiplying by 3, which is divide by 3 to both sides, these will cancel out, and I get d is equal to 30 over 3, which is just 10. d is equal to 10. d is equal to 10. They are identical, just different ways of doing the same thing. Okay, let's move forward. I didn't work in show you no problems, so what I'm going to do is I'm going to say that this is show you no, and this one is also a show you no problem. They're sick, apparently. So I'm going to do this one, and I'm going to do this one, and you are going to attempt these and check your answers. Okay. Method 1. This is the one where you are dividing first. So I want you to practice both methods so that you are able to do it either way. Divide first, so this is being multiplied by 3, and the reason I can divide by 3 on both sides, unlike the other one, is because the multiplication of 3 affects everything. So if I divide the whole thing by 3, I can get rid of that thing because it's already affecting everything. It's only when it's like just 3x, not when it's multiplied by the whole thing. All right, so I got rid of that, and let me just confirm I divided by 3. Okay, so I have x plus 5 left is equal to 36 divided by 3, which is 12. Now I need to get rid of this 5, so the opposite would be minus 5. I can get rid of that, and that's minus 5. So x is equal to 12 minus 5, which is 7. Here, divide by 4 on both sides. That gets rid of this. I have p minus 6 is equal to 36 divided by 4, which is 9. And then I still have this minus 6 here, so the opposite of subtracting by 6 is adding by 6. So I can add 6 to both sides, which cancels that out. And I have p is equal to 9 plus 6, which is 15. Okay? So these are the two answers I did. And I want you to try doing these two and then checking your answers on the next page here. Here's what I did, and here's what I got. I got y is equal to 3, and a is equal to minus 5. If you didn't get those, then now would be a good time to ask a question, or you can just check through your work. Okay, next one. Same thing. Show you no. I want you to try these two after I do the first top line. Method 2, remember, is to use the distributive property. So I'm going to distribute minus 2 times a is minus 2a. Minus 2 times 4 is minus 8. And that's equal to 18. Now I'm looking at this. So I distributed first, and I need to get rid of the minus 8. The opposite operation of that is plus 8 to both sides. Now I have minus 2a is equal to 18 plus 8, which is 26. I still need to get a by itself, and it is being multiplied by negative 2. The opposite operation would be dividing by negative 2, and I'll do that to both. That's a 3, minus 2. And to both sides, get rid of that, and I'll write it over here. Running out of space. A is equal to minus 13, and it's minus because that's minus and that's positive. So when they're different signs, remember it has to be negative. Negative 13. Distribute here, minus 3r, and then plus 15, double negatives, so it's positive, is equal to minus 27. Now I'll get rid of the, I forgot that again, I'll get rid of the positive 15 by doing negative 15 on both sides. So I have minus 3r is equal to minus 27 minus 15 is minus 42, I hope. And then I'm going to do dividing by minus 3 because it's the opposite operation of multiplying by minus 3. If I do that to both sides, I have double negatives, so these are going to turn positive. And 42 divided by 3 is what? Why am I having so much trouble? Oh, because it's late. Okay. I don't know why I can't do that in my head right now. Of course it's 14. Okay, so that is positive 14, which means that r is equal to 14. Now it's your turn. Distribute and solve. Give that a try and check your answers on the next page. Here are the answers. Is that what you got? Y is equal to minus 2. C is equal to 16. Hopefully it is. Okay, finally we are at the last page of this video, and we are at the last slide completely, 36 out of 36 of the entire unit. Let's do this, and then it's time for review, I suppose. One thing that I'll point out on this example here, remember that even though it's invisible, there's a 1 there. Minus something is the same as minus 1. You can multiply 1 or by anything, right? And it just stays itself. It doesn't change. So even though it just looks like there's a minus there, that's actually minus 1. We're just really lazy as mathematicians, and we don't want to put the 1 because it's a lot of work to just do that, right? I mean, did you see that? That was pretty hard. So we don't like it. That's just the way it is. All right, minus 14 minus x is equal to 15. We are going to choose a method, and then I don't know which one we're going to go with, but we'll try to alternate it and try to figure out what method is best in the situation we have, and just go for it. So this is a minus 1. If I use method 1 and I just divide by minus 1, what have I really done? Well, I just really changed 15 here to be negative. That's all that really happens. That seems like it's pretty easy. If I go minus 1 and I distribute it in, then I'm changing all the signs of these. So that's like double the work. I'm lazy. All right, let's do the easy way. I'm going to use method 1 here. I'm going to divide by negative 1 on both sides. So this will cancel out, this will cancel out, and all I'm left with is 14 minus x is equal to minus 15. Now, at this point, I'm realizing that doing method 1 was actually the wrong choice. And the reason it's the wrong choice is I thought I was going to be reducing the amount of work that I was doing, but in doing so, I have a minus x, which means when I get to the end, I have to divide by negative 1 again to make it a positive x. We're just going to go through it anyway, so we can kind of see how that works. Then I'll kind of point out how I should have done it before. So now I have minus x, and I have positive 14, and minus 15. So if I want to get x to be by itself, I will have to do minus 14 on both sides. That gets rid of this, but I have minus x here is equal to minus 29. Now I have to divide by negative 1 or multiply by negative 1. It's the same thing here. And that'll cancel these negative signs out. They're positive. So I have x is equal to positive 29. All right. It's not like that it was that bad. But just as a comparison, real quick, what I could have done instead is distribute. And if I distributed it, then I would have gotten minus 14, yeah, but then I would have gotten positive x is equal to 15. And then I just have to do the opposite of minus 14 is plus 14 to both sides. So x is equal to 29. That was actually easier. That was method 2. So method 2 would have been smarter, but I went with method 1 because I didn't really think it through. But I am going to think it through on the next one because I noticed that this is a minus 5 and this is a positive x. So if I distribute, that's going to be a negative x, isn't it? And then I'm going to have the same annoying problem. So I'm not going to distribute. I'm going to go back to number 1, which is divide by negative 5 on both sides. This is gone. And I have x is minus 3 is equal to 11, negative 11 over 5. Oh, now I feel stupid. See, it's going to still have an answer because I can just like do plus 3, and it's going to be x is equal to minus 11 over 5 plus 3. But now I have to worry about getting the same denominator and turning it into a fraction, which it's not a big deal because I could just go 5 over 5, and now this is 15 over 5. And then I just combine them to be x is equal to 4 over 5. You know, that's not that bad. But I wonder how it would have turned out the other way. Would it have been the same? Think about it. If I had... Instead, I had distributed here. Would it have been any better? I would have had negative 5x, yes, but then I would have had positive 15, and then I would have taken that positive 15 and moved it to the other side as a negative, so I would have had negative 4, yes, and then I would divide by 5, and it would have just turned itself into a fraction, and I would have not needed to do this whole conversion. Why do I keep choosing the wrong thing? I'm really upset at myself right now. But in the end, you know, they all get to the same place. Okay. And I guess that's a good lesson too. Like if you are finding that the method that you chose is hard, try the other one. It might just be a whole lot easier. I guess, right? So don't give up. Try another way. All right, I tried 1 and 1 twice unsuccessfully. Let's try 2. Hopefully that's going to be better. It's probably the wrong choice because I just keep seeing, I keep making the wrong choice, but whatever. Let's go with it. Method 2 is distribute. So let's distribute this in. I know already that that's the wrong choice because, you know, 28 divisible by 7 very easily. I should just do that. But for practice, let's do this. 7 times x, 7x. 7 times 4 is, guess what? 28. Okay? And that's equal to 28. Hey, it actually works out pretty good here. Minus 28 to both sides. And that means it's 7x is equal to... why am I bad at zeros? That's a 0. Is equal to 0. Now it's also equal to an elf. And if I divide by 7 on both sides, well, 0 divided by 7, that's just 0, so x is 0. Yeah. And we can actually remember that you can always check your answers. And I'll just point that out here. If you feel like something's not right, check your answer. X is equal to 0. If we substitute it in, because we know how to substitute, it should balance out. 0 plus 4 is 4. 7 times 4 is 28. So 28 is equal to 28. Perfect. I know that that answer is correct. Here, that one that was really hard with the fractions and stuff, I have 4 over 5 minus 3. Oh, this is kind of a pain in the butt. But 3, and I have to turn it over 5. So that's the same as 15 over 5. So that would be, yeah, it does work out because it's going to be minus 5 through. These are all going to cancel. It'll work out perfectly. But I really wish I didn't choose that one to model here. This one's a little easier. Let's substitute that in. We have 29, so 14 minus 29 is minus 15. Minus 15 is positive 15, so 15 is equal to 15. All of these can be tested. And, you know, that's one way to be certain on these questions that you got it right. Okay, finally, we have reached the end. And we can stop and I can sleep. Woohoo!